by letting F inverse composed with G inverse of A be equal to B, prove that F inverse composed with G inverse of X is equal to G of composed with F, all of that inversed X. What this is saying is that if you take the inverses separately or together, you have to swap the order of the functions. So if you do the inverses separately and then compose the answers, it's in the opposite order to if you compose the functions and then take the inverse. This is quite an important and useful result for analyzing inverse functions. Let's have a look at how we can prove it. So we've been told to use this or otherwise, but let's use what we've been told to use. So F inverse composed with G inverse of A is equal to B. The first thing I'm going to do is I'm going to take F of both sides. So I'm going to do F of this whole thing, F inverse G inverse of A, and that is going to be equal to, as long as I do F of both sides, they remain equal. So that's the same as F of B. I've done F of both sides, so it remains equal. Now simplifying this, F of F inverse, they cancel each other out because that's how inverse functions work. So we just get left with G inverse of A here, and on this side F of B. Now I'm going to do the same thing with G. I'm going to take, let's do it on a new line, I'm going to take G of both sides. So I'm going to take G of that and G of that. So G of G inverse of A and G of F of B. Simplifying again, G of G inverse, just they cancel each other out, so I get left with A. This side I get G of F of B. So if this is true, then A is equal to G composed with F of B. And notice the order has swapped. This was F and then G. This is now G and then F. Okay. So now that we have that, how can we show that these two things are the same? Well, actually, we're basically there. Because if we know that A is equal to G composed F of B, by the basic rules of inverse functions, that means that G of F inverse of A is equal to B. The inverse of the output is equal to the input. But if G of F inverse of A is equal to B and F inverse of G inverse of B, then they must be equal to each other. So that means that F inverse composed with G inverse of A is equal to G composed with F inverse of A, which is exactly what we wanted to prove.